So we're going to talk about arithmetic sequences, which is a pattern, a specific type of pattern we can look at in Algebra 1. So what is an arithmetic sequence? Well, let's start with what is a sequence. So a sequence is basically any list of numbers that are written in a particular order, right? And each term, which is each number, has a position. So if you look at this example right here, we have a first number, which is your first position, second position, third position, and it's going to go on and on and on forever to the nth position. And then we use a as the notation, the variable for the term, and then the subscript tells us what position this is. So the nth position, if you can't really see that, we're going to represent that as a sub n. For example, the first position is a sub 1, the third position would be a sub 3. Right? So we want to make sure we know what that means. Again, so a sub 1 just means the first term in this sequence. A sub 3 is the third term in that sequence. A sub n is the nth term. And the nth term means anything you want, like the 15th term, the 20th term, the third term, the fourth term, right? The n just represents a number. Now, an arithmetic sequence, which is our big idea today, is a specific sequence where the difference between each consecutive terms are the same. So what you're looking at here, for example, you have 5, 10, 15, 20. We can find what's called the common difference, which is that number we add or subtract to go between from one number to the next. That's called the common difference. And you can find it by basically subtracting a sub n and then a sub n minus 1. So that means that term minus the original. So for example, if you look at example A, I want to figure out the next three terms, and you might be able to look at this and figure out the common difference, but let me show you what I meant by a sub n minus a sub n minus 1. So negative 2 is a sub 1, 6 is a sub 2, 14 is a sub 3, 22 is a sub 4, and so on. So to find that common difference, oh, sorry, two words there, running a little too close together. What you want to do is you want to take, for example, a sub 2 minus a sub 1, right? A sub 3 minus a sub 2, a sub 4 minus a sub 3, and check if these are all the same. So it's basically the same idea as checking for a common ratio type thing, right? But instead of having x and y, we only have one set of numbers here. So I'm going to go ahead and do 6 minus negative 2, right? 14 minus 6, and then 22 minus 14. And what do you know? These all end up being 8. So that's a positive 8, so I'm adding 8 each time. So that's basically my pattern. So to find the next three terms, I'm simply going to add 8 every time. So 22 plus 8 is 30, 30 plus 8 is 38, 38 plus 8 is 46. Okay? So pretty straightforward. Go ahead and try number 1, 2, and 3. And if you have some difficulty with the mixed number, remember you can always change a mixed number to an improper fraction if that helps, or to a decimal. So for example, 3 and 3/4 is the same thing as 3 times 4 is 12 plus 3 is 15, so that's 15 over 4, or 3.75. All right, so feel free to deal with those mixed numbers however you will, and let's come back and check 1, 2, and 3. So go ahead and check that work. Remember, you want to make sure you've identified the common difference, right? And then determine those next three. And that common difference could be a addition or subtraction, right? It just depends on if you're getting bigger or smaller. So let's see what happens next when we graph arithmetic sequences. And you might be wondering, how do I graph this? Because I only have one set of numbers. Well, what you can do is you can basically create a table. And your table would be your term, right, which is your n value. And then the number in the sequence, right? Which is your a sub n. So what I can do is I can actually create a table, and again the term, for example 1, corresponds to 24 because that's the first number in the sequence. Then the second number is 18, the third number is 12, and the fourth number is 6. And then each of these becomes an ordered pair, right? 1, 24, 2, 18, 3, 12, 4, 6. And then you want to think, what's the independent and what's the dependent? Well, the number depends on the term we're looking at. So n should be my x-axis, and a sub n is my y-axis. And then I can go ahead and plot this. All right, so 0, 1, 2, 3, 4, and then I'm going up to 24, so I might choose to go up by 3, so it's not all too squished together. Right? And then I'm going to go ahead and plot my points. And then we want to see, what do we notice with the graph of an arithmetic sequence? Well, this should look familiar, right? It creates a line, or the graph is linear. So that's a way to double check if something is arithmetic. Not only look for the common difference, but if you plot it, it should make a line. So if we look at C, is that an arithmetic sequence? Remember again, we should look for the common difference and then check if the points make a line, right? We can double check that. How can you tell the common difference? Well, you're just taking the y's. So you can do 6 minus 4.5, 4.5 minus 3, 3 minus 1.5, and this is already giving me a common difference. So I can say that this is an arithmetic sequence because it has the same common difference between all your terms. You can also say it is an arithmetic sequence because the graph is linear. Oops, it's getting a little messy there. Oh my gosh. So because the graph is linear, and there is a common difference of 1.5 between the terms. So you don't actually have to check both. I think it's worthwhile to double check that, but one or the other would have been a great explanation. Okay, go ahead and try 4, 5, and 6. And one thing I want you, oh, and 7, sorry. And one thing I want you guys to double check, because I fixed it here when I realized it, but I forgot to fix it before your copy. This should be a 0.6. On your papers it says a 0.2, so make sure you fix that. All right, so go ahead and try 4 through 7 for me, and we'll come back and check. All right, so go ahead and check. And one thing I forgot to mention earlier, make sure you are labeling your axes, like not just x and y, but n and a sub n, or you can say term and value, or term and number. We want to make sure we have our labels correct, okay? And 7, either one of these would have been fine. If you wrote both, that's great, but I only needed one or the other. And if you're saying there's no common difference, definitely show me the work to prove that there's no common difference. Okay, we'll finish the rest of this in class on how to write arithmetic sequence as functions, which is, remember, the overall concept for this whole chapter. But come back to class with questions if you have any about identifying or recognizing an arithmetic sequence.